The next topic is compound microscope. Compound microscope is a device to see very tiny objects in a magnified way. It consists of two convex lenses. One is objective lens and the other one is eyepiece or eye lens. The focal length of objective lens is very small and the focal length of the eye lens is larger than the focal length of the objective lens. Now, learn how to draw the diagram when the final image is formed at the least distance of distinct vision. What we do, we'll first draw the objective lens. This is the optic axis. This is the optic center. Now, when the image is to form on the right side, the object should be slightly away from the focus of the objective lens. Let the focal length is f(o) and the distance of the object from the lens is say. This is u(o). What else? One ray parallel to the lens will move and will pass through the focus of the lens. Another ray will pass from the optic center and it will go without any deflection. This is the way how to draw the diagram. Now, the final image of this is formed at this point. Now, if the final image by the compound microscope is to form at the least distance of distinct vision, then this final image that will work at the object for the objective eyepiece should be within the focal length of the eyepiece. So this will be the focus of eyepiece. This was the focus of objective lens, and this distance is focal length of the eyepiece. Same distance. This is optic center. A ray going parallel to the principal axis will pass through the focus of the eyepiece, and another ray will pass from the optic center. And when we extrapolate these two rays will meet at a point here, and this is your final image. If I draw the line, it's quite say like this. This distance of the image from the eyepiece is d. This is least distance of distinct vision, and this distance of the object from the eyepiece is ue. The distance of the image formed by the objective lens is vo. This is the size of the object and this is the size of the image hs. This is the way by which we can draw the image in the form of, in the case of compound microscope, when finally the image is formed at the least distance of distinct. Now our next target is to get the value of magnification. For magnification we again go for the angular magnification, and angular magnification is the angle formed by the image to angle formed by the object when it is kept at the least distance of distinct vision. Now when the object is kept at the least distance of distinct vision, the angle formed will be alpha. This is the height of the object. For the magnification, m will be, this is angular magnification. I must write it here, angular magnification m, and this will be given as tangent beta upon tangent alpha. What is the value of tangent beta? Tangent beta is equal to h dash upon ue. Just write it, h dash upon ue and tangent alpha is h upon d. On solving this, let us see what we are getting. We are getting it as h dash upon h into d upon u. If you see it, this h dash upon h is magnification by the objective lens. The size of the image to the size of the object. You can write it as m. And what is d upon ue? It is distance of the image to distance of the object for the eyepiece. So this will be equal to m. Now the final magnification m is the product of magnification by the objective lens and the eyepiece. Now we can write it as MO. MO could also be written as VO upon UO. Distance of the image by the objective to distance of the object from the objective into ME. Now in the case of ME, we have seen in the case of simple microscope, when the final image is formed at the least distance of distinct vision, in that case the magnification comes out to be 1 plus d upon fe. Now this is the magnification formed by the compound microscope when the final image is formed at the least distance of distinct vision. Now we can add one more point here also. The object is kept very close to the focus of the objective lens. So we can put the value of VO as object is, I must write it here, object is very close to focus of objective lens. So we can write VO as UO as minus alpha, and we can imagine that the image by the objective is formed very close to the eyepiece. So we can write VO as the total length of this tube. So the length of the tube could be written as L. This is approximation. So we can write VO as L. So VO will be written as L, and by substituting these values, we can get the value of magnification by the compound microscope when the final image is formed at the least distance of distinct vision as M is equal to minus VO, that is L, UO, that is FO. Since it is minus FO, therefore I put minus here, and in bracket 1 plus d upon Fe, where Fe is the focal length of the eyepiece. That's all. Thank you.